100 millimeters of armor, 88 millimeter cannon, 57 tons of German engineering, 51 millimeters of armor, 75 millimeter gun, 30 tons of American production, 1 German Tiger, 5 American Shermans. The Tiger could kill all 5 before they got close enough to fight back. This happened over and over. Normandy, Italy, North Africa. American tank crews learned to fear the Tiger more than any other weapon in the German arsenal. Why couldn't 5 American tanks beat 1 German? The answer is mathematics, physics, and industrial philosophy. This is the story of 2 machines that defined World War II tank warfare, and why one dominated the battlefield while the other won the war. The M4 Sherman medium tank entered American service in 1942 as the United States mobilized for total war against Germany and Japan. American military planners knew they needed a tank that could be mass-produced by the thousands, shipped across 2 oceans, maintained by crews with minimal mechanical training, and operated effectively by soldiers who had never seen a tank before Pearl Harbor. The Sherman was designed to win through overwhelming numbers rather than individual superiority. This was America's strategic advantage, the ability to outproduce any enemy, build more tanks than Germany could destroy, replace losses faster than the enemy could inflict them, win through industrial capacity rather than engineering excellence. The Sherman embodied this philosophy perfectly. Every design choice prioritized mass production and ease of operation over battlefield performance. The Sherman's basic specifications were adequate for the tank battles of 1942, but would prove dangerously insufficient by 1944. The tank weighed approximately 30 tons in its standard configuration, making it light enough to cross most bridges and be transported by existing ships and trains without requiring specialized equipment. The main armament was a 75 millimeter M3 gun capable of firing high explosive shells against infantry and fortifications or armor-piercing rounds against enemy tanks. Against German Panzer III and Panzer IV tanks encountered in North Africa, the 75 millimeter gun was sufficient. Against later German heavy tanks, it was completely inadequate. The armor protection consisted of 51 millimeters of rolled homogeneous steel on the front hull and 76 millimeters on the turret front, both set at angles to improve effectiveness against armor-piercing shells. The engine was a gasoline-powered Continental radial, producing 400 horsepower, giving the Sherman a top speed of approximately 40 kilometers per hour on roads and reasonable cross-country mobility. The crew of 5, commander, gunner, loader, driver, and assistant driver, could be trained to operate the tank effectively in just a few weeks, compared to months of training required for more complex German tanks. American factories produced Shermans in staggering numbers that no other nation could match. Over 49,000 Sherman tanks rolled off American assembly lines between 1942 and 1945, more than any other tank in history. General Motors, Chrysler, Ford, and other manufacturers converted automobile production facilities to tank production and achieved economies of scale that were impossible for smaller German factories. Sherman production peaked in 1943 at over 1,000 tanks per month. This production rate meant that American forces could absorb catastrophic tank losses and replace them within days or weeks. If an entire tank battalion was destroyed in combat, replacement Shermans could be shipped from the United States and arrive at the front lines before the surviving crews finished their paperwork. This industrial advantage shaped American tank tactics throughout the war. Commanders knew they could trade Sherman losses for tactical objectives because replacement tanks were always available. But the Sherman had critical deadly weaknesses that American tankers discovered very quickly in actual combat. The 75 millimeter main gun could not penetrate the frontal armor of German Tiger or Panther tanks at normal combat engagement ranges of 800 to 1,200 meters. Sherman crews had to maneuver to extreme close range, often less than 400 meters, to have any hope of penetrating heavy German armor from the side or rear. This meant crossing hundreds of meters of open ground under fire from German tanks that could easily destroy Shermans at twice that distance. The Sherman's own armor was woefully inadequate against German anti-tank weapons. The 51mm front hull armor could be penetrated by virtually every German tank and anti-tank gun from 1,000 meters or more. When a German armor-piercing shell penetrated a Sherman, the results were almost always catastrophic. The gasoline engine, stored ammunition, and hydraulic fluid created an instant inferno. The Sherman's tendency to catch fire when hit earned it the grim nickname Ronson among American crews, after the cigarette lighter company whose advertising slogan was, "Lights first time, every time." German soldiers called them Tommy Cookers for the same reason. These nicknames represented dark humor from men who knew their tank was fundamentally inadequate for the battles they were ordered to fight. The crew survivability statistics were horrifying. When a Sherman was penetrated by enemy fire, the crew had approximately 20% chance of survival. 4 out of 5 men were killed or severely wounded. The internal layout of the tank meant that an armor-piercing shell entering the fighting compartment would fragment and ricochet inside the hull, striking multiple crew members with lethal metal fragments traveling at supersonic speeds. The ammunition stored throughout the hull would often detonate seconds after the initial penetration, creating a massive explosion that killed anyone who survived the initial hit. Experienced Sherman crews knew these statistics intimately. They knew that in any engagement with a Tiger tank, their survival probability dropped to single digits. They climbed into their tanks anyway, because that was their duty, but they were under no illusions about their chances. Tank replacement crews arrived at the front constantly, because experienced crews were killed constantly. Some Shermans went through 4 or 5 different crews in a month of combat operations. American tank doctrine attempted to compensate for the Sherman's technical inferiority through superior tactics and numerical advantage. Sherman platoons of 5 tanks were trained to work together as a coordinated unit. When encountering enemy armor, the standard tactic was for 1 or 2 Shermans to engage from the front, drawing the enemy's attention and fire, while the other 3 or 4 Shermans maneuvered at high speed to flank positions where they could fire at the thinner side and rear armor. This tactic worked reasonably well against German Panzer III and Panzer IV tanks, which could be destroyed by 75mm fire from the side. Against Tigers and Panthers, flanking was far more dangerous because even the side armor was often too thick for 75mm penetration, and the German crews were trained to reverse rapidly to prevent flanking maneuvers. American commanders accepted that destroying a single Tiger or Panther would cost 3 to 5 Sherman tanks. This was considered an acceptable exchange rate because America could replace 5 Shermans faster than Germany could replace 1 heavy tank. The mathematics of attrition warfare favored American industrial capacity, but the individual tank crews paying the price in blood understood that being on the losing end of a 5-to-1 exchange rate meant they were probably going to die. By mid-1944, American industry began producing improved Sherman variants in response to desperate requests from frontline commanders. The M4A3E8 Easy 8. Sherman featured improved suspension, a more powerful 76mm gun that could penetrate German armor more effectively, and additional armor welded to the hull front. British forces developed the Sherman Firefly, mounting a powerful 17-pounder gun in a modified turret that could finally penetrate Tiger armor from the front at reasonable combat ranges. These improved Shermans gave American and British crews better odds of survival, but they arrived too late for thousands of tankers who had already died in original model Shermans. Even the improved versions remained inferior to German heavy tanks in direct combat. The fundamental problem was never fully solved. The Sherman was a medium tank being asked to fight against heavy tanks in a role it was never designed for. ACT-2. The Tiger dominates 6-12. The Panzer Kampfwagen. 6 Tiger I heavy tank represented a completely different design philosophy from the Sherman. Where American engineers prioritized mass production and ease of use, German engineers prioritized battlefield dominance and individual superiority. The Tiger was designed to kill any enemy tank from ranges where the enemy could not effectively fight back. It was intended to operate as a breakthrough weapon, punching through enemy defenses and creating panic through sheer firepower and invulnerability. The Tiger succeeded brilliantly at this mission, becoming the most feared tank of World War II despite being produced in tiny numbers compared to Allied tanks. Every Allied tank crew dreaded encountering a Tiger because they knew the encounter would probably be fatal. The Tiger's specifications were absolutely terrifying to anyone unfortunate enough to face one in combat. The tank weighed 57 tons, nearly double the Sherman's weight, and that mass was mostly armor. The front hull armor was 100 millimeters thick, almost twice the Sherman's 51 millimeters. The turret front was 100 millimeters. The side armor was 80 millimeters. Even the rear armor was 82 millimeters thick. This meant the Tiger had effectively no weak points that Sherman crews could easily exploit. Attempting to flank a Tiger was almost as dangerous as facing it head-on, because the side armor was still thick enough to defeat most Allied anti-tank weapons. The Tiger's armor scheme used thick flat plates rather than sloped armor like the Sherman and Soviet T-34. German engineers calculated that 100 millimeters of flat steel was more effective than thinner sloped armor against the armor-piercing ammunition being used in 1942 and 1943, and combat experience proved them correct. Standard Allied anti-tank guns simply bounced shells off Tiger armor without causing any damage. Sherman 75 millimeter guns could not penetrate a Tiger from any angle at any range. This made the Tiger effectively immune to the most common Allied tank. The Tiger's main armament was the legendary 88 millimeter KWK 36L/56 cannon, one of the most effective anti-tank guns ever developed. This weapon was originally designed as an anti-aircraft gun, but proved devastatingly effective against ground targets. The 88 millimeter gun could penetrate 100 millimeters of armor at ranges exceeding 1,000 meters, which meant it could destroy a Sherman from any angle at any combat range with a single shot. The high-velocity armor-piercing rounds traveled at over 800 meters per second and punched through Sherman armor like it was paper. Tiger crews could engage enemy tanks from 1,500 to 2,000 meters, well beyond the effective range of Allied tank guns, and destroy them with first-round hits. This gave Tiger commanders an enormous tactical advantage. They could position their tanks in hull-down positions where only the turret was visible, making them even harder to hit, and systematically destroy advancing Allied armor without serious risk to themselves. The psychological impact of the 88 millimeter gun was almost as important as its physical effectiveness. Allied tank crews knew that a Tiger could kill them from ranges where they could not see the Tiger clearly enough to return fire. They knew that crossing open ground where a Tiger might be positioned meant accepting that multiple tanks would probably be destroyed before anyone even located the Tiger's position. This created a profound sense of helplessness and dread. Some Allied tank crews simply refused to advance when reports indicated Tigers in the area, requiring threats of court-martial from their commanders to get them moving. This was not cowardice. It was rational assessment of survival probability based on horrifying experience. Veterans taught replacement crews the brutal statistics. If you see a Tiger first, you might survive by running. If the Tiger sees you first, you are already dead. The Tiger's armor scheme and powerful gun made it virtually invulnerable to most Allied weapons throughout 1943 and much of 1944. British 6-pounder anti-tank guns could not penetrate Tiger armor at any range. American 75mm anti-tank guns were similarly ineffective. Even American 76mm anti-tank guns needed to hit the Tiger's side armor from less than 500 meters to guarantee penetration. Only specialized weapons like the British 17-pounder gun, American 90mm anti-aircraft guns adapted for anti-tank work, and later American 76mm guns with HVAP, high-velocity armor piercing, ammunition could reliably penetrate Tigers from the front. These weapons were not widely available until late 1944 and early 1945. For most of the war, Allied tank crews faced Tigers with completely inadequate weapons and had to rely on desperate tactics, overwhelming numbers, artillery support, and airstrikes to deal with them. Direct tank versus tank combat against Tigers was avoided whenever possible because the casualties were so catastrophic. The Tiger's main weaknesses were mechanical reliability and operational complexity, rather than combat performance. The tank was over-engineered with complex mechanical systems that required constant maintenance. The Maybach HL230P45 engine produced 700 horsepower, but consumed fuel at an alarming rate, approximately 300 liters per 100 kilometers on roads and even more off-road. This gave the Tiger a combat radius of only about 100 kilometers before needing refueling, severely limiting operational flexibility. The transmission and final drives were stressed beyond their design limits by the tank's extreme weight, leading to frequent breakdowns that could strand a Tiger far from repair facilities. The overlapping road wheel design provided excellent cross-country performance, but was prone to jamming with mud and debris in winter conditions, sometimes immobilizing the tank completely. Tigers required hours of maintenance for every hour of combat operation. Crews spent most of their time performing repairs rather than fighting. Despite these mechanical problems, when Tigers were operational, they were nearly unstoppable. The combat effectiveness of a working Tiger was so high that Allied commanders developed specific doctrines for dealing with them. Isolate them with infantry, call in artillery strikes, request air support, do anything to avoid direct tank combat. Germany produced approximately 1,350 Tigers between 1942 and 1944, a tiny fraction of the 49,000 Shermans built during the same period. This massive production disparity explains why Tigers were rarely encountered even though they dominated battlefields where they did appear. But the kill-loss ratio tells a more nuanced story about effectiveness versus numbers. Each Tiger destroyed an average of 5 to 10 Allied tanks before being knocked out, whether by enemy fire, mechanical breakdown, or crew abandonment. Some Tiger aces achieved far higher ratios. SS Obersturmführer Michael Wittmann destroyed 138 Allied tanks during his combat career, most while commanding Tigers, while Otto Carius, another legendary Tiger commander, destroyed over 150 enemy tanks. These exceptional kill ratios demonstrate what the Tiger was capable of in the hands of skilled, experienced crews. The Tiger forced Allied armies to completely change how they approached armored warfare. Instead of tank versus tank battles, Allied commanders used combined arms tactics, overwhelming artillery, and air superiority to neutralize Tigers without risking their own tanks in direct combat. This was admission that the Tiger was simply too dangerous to fight fairly. ACT-3. The Mathematics of Death, 1200 to 1500. The raw numbers explain why Sherman crews were terrified and Tiger crews were confident. Armor thickness, gun penetration capability, effective engagement ranges, and crew survival rates were all quantifiable factors that determined combat outcomes with brutal mathematical certainty. Sherman crews understood the calculations and knew they were on the wrong side of the equation. Tiger crews knew they had overwhelming advantages. When armor-piercing shells meet steel plate at high velocity, courage and training become irrelevant. Only physics matters. Sherman armor at 51 mm thickness versus Tiger 88 mm gun at 100 mm penetration means the Sherman loses every single time. Tiger armor at 100 mm thickness versus Sherman 75 mm gun at 60 mm maximum penetration means the Tiger is effectively immune. The mathematics were not close. They were completely one-sided. Sherman crews needed miracles to win. Tiger crews just needed to not miss. Combat engagement ranges in Northwest Europe typically occurred at 800 to 1,200 meters in open terrain, like the Normandy Bocage country or the plains of Belgium. At these ranges, Tiger 88 mm guns could destroy Shermans with first-round hits, while Sherman 75 mm guns could not penetrate Tiger armor even with perfect accuracy. A Sherman at 1,200 meters from a Tiger was already dead. It just did not know it yet. The Tiger could fire. The shell would arrive at the Sherman in approximately 1.5 seconds, penetrate the armor, and kill the crew before the Sherman crew even heard the sound of the shot. Sherman crews had to close the distance to 400 meters or less to have any realistic chance of penetrating Tiger side or rear armor. That meant crossing 800 meters of completely exposed killing ground while under fire from the most effective anti-tank gun in the world. Sherman maximum speed was 40 kilometers per hour, approximately 11 meters per second. Crossing 800 meters at full speed required 72 seconds. A trained Tiger crew could load, aim, and fire the 88 mm gun every 6 to 7 seconds. That was 10 to 12 shots during a Sherman's approach. Tigers rarely missed at these ranges. The mathematics meant Sherman platoons attempting to close with a Tiger would lose 3 to 4 tanks before survivors got close enough for side shots. Often all 5 tanks were destroyed before reaching effective range. The crew's survivability statistics were equally brutal and quantifiable. When a Sherman was penetrated by armor-piercing fire, the crew had approximately 18 to 20% survival rate. The armor-piercing shell entering at supersonic velocity created metal spalling, tiny fragments of the tank's own armor breaking off and ricocheting through the interior at lethal speeds. These metal fragments struck crew members like shotgun pellets. The driver and assistant driver in the front hull had virtually no chance if the shell entered through the front armor. The commander, gunner, and loader in the turret were killed or critically wounded by spalling and the pressure wave from penetration. If the ammunition stored in the hull detonated, which happened in approximately 60 to 70% of penetrations, everyone died instantly. The complete destruction of the tank through ammunition explosion was so common that Allied medical personnel rarely found recoverable bodies in destroyed Shermans. When Tiger armor was penetrated, which was rare, the crew had better survival rates due to the tank's larger internal volume and ammunition storage in separate compartments, though casualties were still significant. Sherman crews knew these statistics intimately because they were briefed on them during training, and because they witnessed them constantly in combat. New replacement crews would arrive at the front, be assigned to a Sherman that still had blood and burn marks from the previous crew, receive a briefing about Tiger capabilities, and then be ordered to advance knowing that their survival probability in a Tiger encounter was less than 20%. This created profound psychological stress that manifested as what we would now call combat trauma, or PTSD. Veterans developed specific symptoms: extreme anxiety when advancing through terrain suitable for Tiger ambush positions, hypervigilance, scanning for the distinctive shape of a Tiger, panic reactions to the sound of 88 mm guns, and survivors' guilt after watching multiple other tanks in their platoon burn while they somehow survived. Company commanders had to deal with crews that became combat ineffective due to fear of Tigers. Some crews simply refused to advance. Others would advance but break and retreat at the first sign of contact. This was not cowardice in the traditional sense. It was rational response to mathematical certainty of death. Act 4. Why the Sherman won the war, 1500 to 1800. Despite the Tiger's overwhelming superiority in direct combat, Germany lost the war, and the Sherman is remembered as the tank that won World War II. This paradox reveals the fundamental difference between tactical effectiveness and strategic success. The Tiger won almost every battle it fought. The Sherman won the war. The explanation lies in industrial capacity, logistics, operational reliability, and the basic mathematics of attrition warfare. Germany could build 1,350 Tigers. America could build 49,000 Shermans. When both numbers reached zero, America still had factories building more Shermans, while Germany had no factories left at all. Superior engineering lost to superior production. Individual quality was overwhelmed by collective quantity. This is the essential lesson of armored warfare in World War II, and it shapes military procurement decisions to this day. The Sherman's advantages became evident when examining operational effectiveness rather than combat effectiveness. Shermans were mechanically reliable and could operate for hundreds of kilometers without major maintenance. When mechanical problems did occur, any competent mechanic could repair a Sherman using common tools and readily available spare parts. Sherman engines used commercial gasoline that was available everywhere Allied forces operated. The mechanical simplicity meant crews could perform most maintenance themselves without specialized equipment or factory-trained technicians. Shermans could be repaired in field workshops within hours and returned to combat the same day. Tigers were mechanical nightmares that required specialized tools, rare spare parts, and days of maintenance for major repairs. Tiger engines used high-quality gasoline that was increasingly scarce as Allied bombing destroyed German refineries. Many Tigers were abandoned, not because they were destroyed in combat, but because they broke down and could not be repaired before Allied forces advanced. Operational readiness rates tell the story clearly. Sherman units typically had 85 to 90% of their tanks operational at any given time. Tiger units were fortunate to have 60% operational, and rates as low as 30% were common. The logistics of deploying and sustaining tanks in combat operations heavily favored the Sherman. Shermans could be loaded onto standard transport ships, landed on beaches using standard landing craft, and driven to the front lines using their own power. The logistics pipeline from American factories to European battlefields was efficient and reliable. Replacement Shermans arrived constantly, often faster than units could integrate them. Tigers required specialized railway transport because their weight exceeded bridge load limits on most European roads. The overlapping road wheels had to be removed and replaced with narrower transport tracks to fit railway clearances, a process that took hours. Tigers consumed fuel so rapidly that supply vehicles could barely keep them operational. A Tiger battalion required dedicated fuel trucks and supply trains that were vulnerable to Allied air attack. American logistics could support thousands of Shermans across multiple theaters of war simultaneously. German logistics struggled to support a few hundred Tigers operating in a single theater. When examining total operational availability, tanks that were not only functional, but also supplied fueled armed and positioned where they were needed, the Sherman's advantages were overwhelming. The production differential was not merely quantitative, but qualitative as well. American factories were physically safe from enemy attack throughout the war, protected by thousands of miles of ocean. German factories were subjected to intensive strategic bombing that progressively destroyed industrial capacity. American production of Shermans increased steadily from 1942 through 1944, peaking at over 1,000 tanks per month. German production of Tigers never exceeded 100 per month and declined steadily as Allied bombing intensified. By 1945, German industry could barely produce any heavy tanks at all, while American factories were still building hundreds of improved Shermans monthly. The industrial contest was never close. American productive capacity was approximately 10 times larger than Germany's even before bombing damage, and the gap widened throughout the war. American factories converted to tank production without compromising production of aircraft, ships, trucks, and weapons. German factories were forced to choose between tanks and aircraft, never having enough capacity for both. The industrial mathematics meant Germany was always losing the attrition war, even when German tanks were tactically superior. The final and most important factor was that American military leadership learned from experience and adapted. By late 1944, American forces had developed effective combined arms tactics specifically designed to neutralize Tigers without accepting catastrophic tank losses. Artillery would saturate suspected Tiger positions with high explosive shells to destroy or suppress the tanks. Fighter bombers would attack with rockets and bombs from angles where the Tiger's thin roof armor was vulnerable. Infantry would advance to spot Tigers and call in fire support rather than exposing tanks unnecessarily. When tank combat was unavoidable, American commanders ensured overwhelming numerical superiority, 10 or 15 Shermans for every Tiger, accepting that half would be lost, but the Tiger would be destroyed. These tactics worked. Tigers were progressively neutralized through operational exhaustion rather than combat defeat. By early 1945, Tiger sightings became rare, not because they were all destroyed in battle, but because Germany had no fuel to operate them, no spare parts to maintain them, and no replacement crews after experienced tankers were killed. The few remaining Tigers were abandoned as Allied forces advanced because they could not be moved or sustained. The Sherman won the war because wars are not won by individual weapons, but by industrial systems, logistics networks, trained personnel, and sustainable operations over years of continuous combat. The Tiger was the better tank in every measurable combat parameter. The Sherman was the better weapon system for total war. History remembers both. The Tiger is remembered with awe as perhaps the most fearsome tank ever built, a machine that dominated battlefields and terrorized enemies. The Sherman is remembered with respect as the tank that equipped the armies that liberated Europe and defeated Nazi Germany. Both memories are accurate. In any individual battle, the Tiger was superior. In the only battle that ultimately mattered, the industrial and logistical struggle to sustain armies in the field for years, the Sherman was superior. That is why the war ended with American tanks in Berlin and German Tigers abandoned as rusting wrecks across Europe. 5 Shermans versus 1 Tiger. The Tiger won that fight almost every time, but there were always more Shermans coming, and eventually, there were no more Tigers. Quantity has a quality all its own. The mathematics of total war proved that lesson definitively. Superior engineering without industrial capacity loses to adequate engineering with overwhelming production. That is the final verdict of Tiger versus Sherman. If you found this analysis interesting, hit that like button. Subscribe for more deep dives into World War II armor and tactics. Drop a comment. Would you rather command a Tiger, knowing you are outnumbered, or a Sherman, knowing you have support coming?